Hi, in this video, we're going to talk about another recursion example, the alternate coin game. So first, let me describe the game. It is a two-player game. I'm going to call the two players I and you, or me and you. And we're going to have a row of coins. Each of these coins is going to have a number associated with it, the value of the coin. And the two players, they will take turns to remove one coin, and we can only remove coins from either end of the road. So just the first coin or the last coin, but not from the middle. And I'll be the one to make the first choice. Now the goal is for me to maximize the total coins that I collect. Now you should also try to maximize your total, or equivalently try to minimize my total. So let's try to play a game. So in this one, the row of coins are 6, 2, 3, and 4. So I'll make the first move. I can take either 6 or 4, the first or the last coin. I'm going to take 6, the largest one. So that's my coins, and 2, 3, 4 are what's left. Now it's your turn. You will also take, I guess in this case, take the biggest one that's left, 4. And so here are your coins, and what's left is 2 and 3. Now it's my turn. I'll take the biggest of the remaining, which is 3. So 2 is left, and now I have 6 and 3. And you took the last one. You have no choice. So you'll take 2, and you have 4 and 2. And when we sum up the total number of coins, for me, that is 9, and for you, that is 6. So that is the maximum possible for me, assuming you also get the maximum possible for you, and I win. Now, so the question is the strategy always take the biggest coin possible? Now, let's try a different row of coins. This time, 11, 20, 5, and 3. So if we follow our strategy to take the biggest coin possible at every turn, so my first choices are 11 and 3, so I'm going to take 11. And then for you, you will take 20, so that's 20. And then for me now, between 5 and 3, I'm going to take 5, and with 3 left. And then you, being the last one, you're going to take the remaining, the last 3. Okay, so if we look at the total, my total is 16, but your total is 23. So as it turns out, the strategy of always going for the biggest coin is not the optimal strategy. So I can do better, right? So can you actually try to figure out the right way for me to take the coins so that I will have more coins than you? Okay, hopefully you figure out a way for me to win, but just briefly, so when I'm making my first choice, instead of going to the biggest coin possible at that point, which is 11, I would go for 3. So I pick 3, and now the best possible choice for you in the remaining coins is really 11. So you will take 11, but now the next turn I can take 20, so that the only remaining coin for you to choose is 5. So when we go like that, I would get 23 and you would get 16. So in playing it this way, I win. Now, so the strategy, if there is one, really is to try all the possibilities. We cannot just go for the biggest one at every turn, right? We have to try all the possibilities, play to the end of the game, and then figure out, okay, the maximum possible choice for me. So the natural way to do this is to use recursion. So if you want to think about the recursion strategy, feel free to pause the video now. I'm going to go over it. So when we talk about recursion, we always think about 3 things, right? What is the base case? What is the recursive case? Or how do we break down the problem into smaller, simpler sub-problems? And then finally, given the solution, to the subproblems, how do we solve the original problem. So the base case for this game is that, well, if there is no coin, then it's really simple, right? Both my total and your total are going to be 0. Okay, so the subproblem, what is it? Well, at every turn, we have two choices. We either pick up the first coin or pick the last coin, right? Now, if we pick the first coin, then we can continue to play the game with the remaining coins. And the total coins would then be that first coin that we pick, right? Plus the coins that we can get from playing the game with the remaining coins. Well, the remaining coins are the row of coins minus the first coin. Same thing if we pick the last coin, then the total would be the last coin that we just picked plus the coins that we get from playing the game with the remaining coins, which again would be the coins minus the last coin. So now we're going to have two totals, and then the solution to the original problem, which is like, should we pick the first coin or should we pick the last coin? Well, given the two totals, then the choice is simply to pick the larger of the two totals, right? Then we know whether we should pick the first coin or the last coin. Now, it is slightly more complicated than that, because depending on whether I am the one making the choice or you're the one making the choice, then we would try to maximize a different total, either my total or your total. Okay, so let's visualize what happens when we use this recursion strategy to play this game where we have a row of coins 11, 25, and 3. Okay, so I'm the one making the choice, so I can either pick the first coin. So in that case, my total would be the first coin plus my total from the rest of the game. Well, I don't know what that is yet, but we're going to figure that out later, right, when the recursion is done. And then your total at that point would be just your total from the rest of the game, right? Because at this turn, I'm the one picking a coin. You're not picking anything. Okay. So, another choice for me at this turn would be, I pick the last coin, which is 3. So my total, if I pick 3, would be 3 plus whatever coins that I get from the rest of the game. And your total is, again, what you get from the rest of the game. And obviously, if I pick 3, then the remaining coins are 11, 20, and 5. And if I pick 11, then the remaining coins are 25 and 3. Now, let's go down on the left branch of this tree. At the next turn, you're the one making a choice, and you have a choice between 20 and 3. Now, if you pick 20, then your total at this point would be 20, the one that you just picked, from and then plus whatever the total coins that you get from the rest of the game. And if you pick 3, your total would then be 3 plus whatever total you get from the rest of the game, right? For me, I'm not the one making any picking any coins here, so my total at this point would be just whatever I get from the rest of the game, right? Same on this branch. And then at this point, I would encourage you to pause the video and try to complete the remaining recursion tree on this side as well as on this side. And assuming you've done that, you're likely going to have a tree that looks like this. Or maybe even this, right? Let's look at this in a little more detail, because that's very important, what happens when we hit the base case. So when we are down to 1 coin and you're the one making the choice, well, it's not much of a choice, right? You have to pick 3. So therefore, at that point, your total is going to be 3 plus whatever's left. And my total is, whatever that is left. Now, whatever is left is, we know what that is. We're going to hit the base case, right? This is going to be just both 0. So then the recursion is done, and the values are going to be propagated back up the recursion tree. So what happens here is, when my total is 0, that number is going to be propagated up the tree. And so my total up here is going to be 0 because, well, I mean, I'm not picking any coins here and there's no coins left. So I'm just going to get 0, right? Now, the same thing, when there are no coins, then your total is going to be 0. However, because at this turn, you pick the coin 3, so your total at this point is actually going to be 3, right? And that's intuitive, right? You have one choice. You have coin 3, so your total is 3, my total is 0. But that's what happens when it hits the base case and things kind of turned around. So what happens next is that it will return my total, which is 0, and your total, which is 3, up this branch. And we are going to fill in those numbers. So here we get here that my total is going to be 5 plus 0, because that's the one that gets added here. And then your total is going to be 3. That comes from here, right? So at this point, then we're going to have a choice to make, right? Because we know going down this branch, my total is 5 and your total is 3. Then what about going down this branch? Well, if we just follow the same exercise, or actually if you're looking at this, right? If you look pick 3, then my total is going to be 3 and your total is going to be 5, right? And then now, so we can then pick between these two choices, right? And who's making the decision? Well, I'm making the decision, and obviously I will maximize my total, which is this one, right? I'm going to pick 5. And even though we go over like all these little details, this actually match our expectation, because, if we have just 2 coins left, we are obviously going to just pick the bigger one. And now we can just follow the same steps that, okay, I've made the choice here and calculated my total to be 5 and 3. We can propagate this information up to this branch here, and that what ends up there is that my total here is going to be 5. That's just from the rest of the game, right? And then your total 3 is going to get added to this 20 here, because 20 is the choice that you're making at this turn of the game. So my total is 5 and your total is going to be 23 at this point. Now, so we know the result going down this branch or picking this 20 here, but we don't know the numbers if we pick, or if you pick 3 going down this branch yet, right? But we can obviously do the same thing, and we can just calculate that. And what we're going to come up with is that if you pick the coin 3 here, then my total would be 20 and your total would be 8. Now, so between these two results, and you're the one making the decision, then obviously you want to get the most coins for you. So you're going to pick 23, which is more than 8, right? So you're going to pick this result, and that result is going to then get propagated up this branch here. So we're going to fill out your total 23 is going to go in here, and my total of 5 is going to come in here, and my total then, if I pick 11, is going to be 16, and your total is 23. So at this point, I would encourage you to again pause the video and complete the remaining parts of this tree so that we can make a choice between should we pick 11 or should we pick 3 here. So assuming you've done that, the rest of the number that we're going to fill out here, my total is going to be 23 and your total is 16. So I'm the one making the choice here, then obviously I will pick the larger number for my total, which is 23, which, as we saw earlier, is the best that I can do, and I win this game. Okay, so now that we have our recursion strategy in kind of a pseudocode, and then we see what happens if we apply the recursion on this particular game, then actually let's work out the code. And here is the code that I wrote. So I'm going to define this function altCoinGame. The input is the row of coins that I'm playing, and I also take a parameter that is me, and if it is true, then I'm the one making the choice, and if it's false, then you, the second player, you're the one making the choice. And what it returns is that it returns my total and your total. Right? And to get us started, remember our base case is there is no coin. So the length of coins, if it's 0, then my total is 0 and your total is 0. Next would be the recursive case or the subproblems. And we know we have two options. One is for the current player to pick the first coin, and the second choice is for the current player to pick the last coin, right? So if the current player picks the first coin, then the remaining coin would be the rest of the coin, right? So we're taking a slice here, and we take off the first coin. So we start at index 1 and all the way to the rest of the coins. And if the current player picked the last coin, then the remaining coin would be the all the coins starting at index 0 all the way, but not including the last coin. So -1 here. And remember, we have to switch players, right? So if I'm the current one playing, then the next time is your turn. So not me, but then if it's me, then this is false. Then the next time is me. So not false, it's going to be true. So either way, the not me is going to switch the player. And we're going to remember the my total and your total from both subproblems. So now that we make the recursive call or solve the subproblems, then we have to make a choice, right? Should we pick the first coin or the last coin? And that depends on whether it's me who's making the decision or you are making the decision. So if it is me who's making the decision, then let's calculate the total for if I pick the first coin. Then my total would be the value of the first coin plus whatever I get from playing the rest of the game, right? And my total from picking the last coin would be the last coin plus whatever the coins that I get from playing the rest of the game, right? And then I would just compare the two. So if picking the first coin is going to give me more coins, more total coins than if I pick the last coin, then that's what I'm going to return, right? So my total, I'm going to pick my total from picking the first coin, and then whatever your total would be. Right? Otherwise, I'm going to return the total from picking the last coin, and then whatever you get by playing the rest of the game. The steps are very similar. If you're the one making the decision, just be careful which number we're adding and which number we're returning, because there are quite a few different variables. But anyway, this is the code for the alternate coin game. So let's test our code. And as always, it's important to have good test coverage. So we make sure that we should test the base case when there are no coins, and the very simple case when there are 2 coins, then obviously we want to pick the larger one for me. And here are the 2 examples that we went through earlier, and here is a game with more coins. So let's run them and check the results quickly. Yeah, so when there are no coins, then my total and your totals are 0. When there are just 2 coins, then my total, I will pick the bigger one, right? And these are the results from the 2 earlier games that we play, and we can also manually verify this one. So there are a few loose ends that I like to wrap up with. One is, if we look at this recursion tree, if we look at parts of the tree that we have here, especially these 2, we see that they are actually exactly the same subtree or subproblem, right? And that's understandable how we get here, because, you know, here we pick 11 as our first choice, and then you pick 3 as your first choice, right? But here on this branch, I'm picking 3, and you are picking 11. So in both of these branches, we will end up with the same subtree. So when there are common subproblems, then what we could potentially do is when we see the subproblem the first time, we'll remember the result, so that when we see the same problem, same subproblem again, we can just return the result quickly without having to do the recursion again. So this can actually speed up the algorithm a lot when the tree is a lot bigger and there are many common subproblems or subtrees. And what this technique is called, it's called memoization. And if we have recursion plus memoization, that would result in a technique called dynamic programming, which is very useful for solving a lot of problems, and a lot of problems fast. And a coding exercise that I would like you to try is that, notice our version of this function returns just the total, right? My total and your total. It doesn't tell us how we arrive at my total, say, for example, you know, how I can actually win the game. It just gives us the one number at the end, right? So I would like you to try to see, how can we modify this piece of code so that we can return the choices that I make along the way to arrive at the final total. And you can return a list of the choices that I make as perhaps the third element in this tuple that is returned by this function. And assuming you've done that, here's the solution. I'm not going to go over it, but I highlighted the additional parts so that you can see how it's done if you haven't done it yourself. And then one more coding challenge I have for you is that, notice in this version of the code, we when we make the recursive call, we take a slice of the coins, right? And taking a slice is actually making a shadow copy. And making a copy is never efficient, especially if we have a lot of coins, right? So it is better if we don't make a copy of the coins, but instead just passing around indexes, like a start and an end index, so that we know which of the coins we can pick from. And so, by default, we should start at 0. The end, we don't know where the end is, so we'll start with none. But if the end is none, then we know the end should be, the length of the coins, right? The last coin. And so a few modifications that you might have to make is, okay, well, now how do we know we hit the base case where there is no coin? And also, how does the start and the end index change when we make the recursive call. And then there's a few minor changes you also have to make in the rest of the code here as well. So I will leave that as an exercise for you. And this concludes the video on the alternate coin game.